Hi there and welcome to this show and tell. In the Open Digital Architecture team, we've built a greater understanding of how the pieces of our puzzle fit together, and as a result we've clarified where and how we have to make decisions and solve challenges. The first piece of this is that the ODA Technical Architecture team are beginning work on a core specification for components that defines functionally what a component does. Following that, in the ODA Component Accelerator, we're starting to collaborate more closely with the Tech Architecture team on two things. A general specification for components that describes the non-core things that a component needs to do, and the corresponding environment specification that describes the underlying platform for those components to run on. The ODA reference implementation, our canvas, is the first practical example of a working environment, and it's helping us to understand the specific considerations for the platform operators to be able to build and maintain an environment that meets the spec and allows seamless integration of components. In addition, we're getting clearer in our documentation on the split between what's part of the component, what's part of the environment, what work the site reliability engineers will need to do to maintain an ODA environment, and what external services the environment and the components expect to be available outside the ODA scope for all of it to function correctly. All of our documentation is on GitHub, and we'll provide links to that as part of this show and tell. The two things I want to highlight now though are service mesh and observability. We've decided that in addition to Kubernetes, we're including a service mesh in the recommendation for the environment specification. The main reason for this is that service mesh is a great way of providing a baseline of security in two areas. First, all service mesh products can facilitate east-west segregation, making it easier to stop components from talking to one another in an unauthorized or unexpected way. Second, it allows us to ensure that without any particular effort on the part of the component provider, we can secure communications inside the environment. In addition though, Service Mesh also provides us with a way of making access to components in the environment easier to facilitate, and it provides us with the ability to make the environment itself observable, producing its own events and metrics related to performance and connectivity. In Lester's demonstration, we'll see how to include observability in components and how that integrates with the ODA reference implementation. But let's quickly talk about observability first. Observability is a catch-all term for organized and integrated collection and analysis of events and metrics that aid us in things like operations and troubleshooting. In the environment specification, we're including the need to collect events and metrics in a consolidated way, and we're testing that now to see how we can make it work for all components and also how we can ensure the data we collect can be passed to analytics platforms outside the ODA scope in the wider organization. As time goes by, we expect to discover more about how components integrate with its environment and the wider organizations they're deployed into, and we'd welcome anyone to join us if you feel you can contribute to the success of the ODA environment.
For the next 20 minutes or so, I'm going to talk you through the observability that we built into the ODA Component Accelerator reference implementation over the last sprint. The work I'm going to talk you through is actually available as well in the Git repository. So if you look in the ODA CA docs, there's an observability tutorial which is the same content I'm going to talk you through over the next few minutes. Now firstly, I want to talk about the actual reference lab environment that we're doing this work in. Now the reference environment consists of like a foundation of a Kubernetes cluster which has been built in the Open Digital Lab by the TM Forum. So it consists of a Kubernetes cluster and also a set of Canvas services. So these are the non-functional services that are made available to all the different components. And then on top of that, you then deploy functional components which can come from any software vendor. So this is the reference implementation. And if I drill down into the Canvas services a little bit more, so the Canvas services consist of a set of non-functional services that are actually, you can have your own canvas and choose different options for these. So for example, the observability is using a lot of the facilities offered by a service mesh, and in the reference implementation we're using the Istio service mesh, and then part of Istio, one of the sub-projects of Istio, is a management interface called Kiali that gives the actual observability. Now you could have your own canvas with your own an alternative service mesh, and that should work. The only thing is that the service mesh has a corresponding controller which actually configures the service mesh automatically from the metadata from the component. And so this is the reference environment that we will be using. Now the component that I'm going to deploy for this demonstration is the reference example component, which again is available in the ODA CA docs part of the ODA repository. It's in the ODA CA docs examples product catalog. So this is like the reference example component. And if you want to run this yourself, then you firstly need to do a git clone of this repository and then follow along with these instructions. So the first thing for me to do is actually deploy that component into this the ODA canvas, and I'm just going to use this very simple command, helm install. R1 is the release name, the helm chart is the product catalog helm chart, and I'm installing it in the components namespace. So that command should kick off the installation of that component into the Open Digital Lab. And what I'm going to do is I'm actually going to first show you the baseline observability almost that you get out of the box with the service mesh. Then I'm going to talk you through how it actually works, and then we can talk about how do we then add custom business metrics from our component, because we can actually have business metrics whatever we wanted to expose. So while that deployment is happening, all I need to do is I need to go into the Rancher environment. So if I open up the Rancher environment to find this observability, it's actually part of the new Rancher interface called Cluster Explorer. So I click on that, and all the new facilities and ranchers are being exposed using this new interface. And I then need to, in the top left, click on Istio, and then Kiali. This is the dashboard, the observability dashboard is part of the Istio project. And if I click on Kiali, and what I'm going to use the graph view. And if I click on this graph view, so you see this is the component that's actually still being deployed. It's still in the process, and the reason there's a red outline is the metrics data showing that this component's not yet ready. And if I just talk you through it, so for now ignore this line going from unknown. This will be part of the second stage of the demonstration. The first thing I want to look at is these square or rounded square boxes. These are microservices, and these triangles are Kubernetes services where you're exposing the features of a microservice. And so if I click on one of these, you see on the right hand side it'll show me some data. Now at the moment I've just asked for this component to be deployed. I haven't sent any traffic to it yet. The only traffic that's coming through is as part of the initialization of this component. And so what I want to actually do is I want to send it some real traffic. Now I've just deployed this component, so how do I know where the endpoints of the APIs are? Well, I can actually do a query for that. Now, because there's this custom resource called an API custom resource, I can actually do a query and say kubectl get API, and this is the custom resource that we created as part of the ODA canvas, and again in the namespace components. And this shows, like that component, it has 3 endpoints. There's the metrics endpoint, which is for the custom metrics I'll talk about in a minute. There's the party role, which is part of the security of that component, and then this is a product catalog component, which has a product catalog management API. And this is actually showing you where it's exposing the endpoint, and because the Open Digital Labs is running on AWS, this is the URL to that endpoint. And so I want to generate some traffic into this, because the observability relies on traffic. So all I do, a very simple way of doing it, is just doing a curl. So if I do a curl to that endpoint, that's my product catalog management. I might go to the catalog resource, and I'm just getting a simple 200 response, and I won't do the same for the party role management API. I just do a curl, and I'm just getting 200 endpoints. But by generating traffic, I can actually then see it in the observability data. So if I go back to Kiali, to this interface, it normally takes a few seconds to come through. You can see the traffic starting to come through now. I'm now seeing this is where my traffic is coming through. It's coming from the Istio Ingress Gateway, and it's hitting this party role API, and it's hitting the product catalog API. And by clicking on one of these links, I can actually then observe. Firstly, I'm observing this is HTTP traffic, so it's recognizing it's HTTP traffic. It's colored in green because I'm getting like an OK response, like a 200 or 2XX response. And at the moment, there's not enough traffic, or it's just enough traffic to start drawing a graph. Now, if I want to see some real traffic patterns, I'll use something like Postman to generate a larger volume of traffic. And I have here a very simple Postman collection, and I can run it like I'm going to run 100 times with a delay of 200 milliseconds, and that'll give me more traffic that I can actually observe in Kiali. You see, I'm creating actually new things in my product catalog. I'm getting 201 responses, which means it's been successful, and it should in a few seconds start to appear in this observability interface. As you can see at the moment, I'm at 100% success rate for these queries, or for these posts into the product catalog, and you just see the traffic volume ramping up. And I can click on any one of these interfaces. So for example, there's a HTTP request into the product catalog API Kubernetes service, which then forwards it onto the actual microservice. And now you see I'm seeing the response times. So the 99th percentile response time for that post is basically 100 milliseconds. And the blue lines here are TCP. So if it's not HTTP traffic, so between the product catalog API and the Mongo database where it's storing the sort of product catalog information, there's a TCP connection, like a Mongo database TCP connection. Here you can't see it can't interpret the results. It doesn't know whether it's successful or not, but you can just see the number of bytes of traffic being communicated over this interface. And so that's the base observability that you get out of the box by having a service mesh. If I intentionally generate some error traffic, you'll see I'm getting non-200 responses. Let me just have a look at an example for that. So I'm just going to use curl again. I'm sending a GET request to a catalog item which doesn't exist. So I should get a 404 error, and I'll run this a few times just to generate some traffic, and then I can observe that in Kiali again. So I sent a 404 request into the product catalog. Again, it takes a few seconds to come through into the time series database, but I should start to see some 400 errors appear. And there we are, you just see now I'm getting some 4xx, which basically saying is a client error. There's either a not found or an unauthorized or these sorts of errors. I'm getting 400 error messages, and you can just about see it start to appear in the traffic graph. So that's the base observability you get just by having a service mesh. Now the question is, how does this actually work? Like, how is this data being generated and getting into Kiali? And then could we use that to build some custom business metrics from our component? So the service mesh, it works by injecting a proxy into every pod that's been deployed into this environment. And what that proxy does is it actually controls the traffic into and out of every pod. And I can actually see this if I go back to my command line. Like if I just query the pods in this component namespace, so these are the pods that make up my component. And what I can do is I can actually do a query to get the containers that are inside one of these pods. And this is the query. You just need to actually put in a real pod name. So I'll look at this product catalog API microservice. So I'm basically saying, get that pod information. I'm interested in sort of the container name that are within that pod. And if you look, there's actual the R1, the release 1 product catalog API microservice. This is part of the the component definition. There's also a proxy, an Istio proxy. This is the Istio putting the Envoy proxy, and it automatically injects it into every pod that's in this component's namespace. And how you tell Istio that you want to automatically inject it is you just put a label against that namespace. So there's a label saying Istio injection true on this component namespace, and then anytime you deploy anything, automatically Istio comes along and it injects this Envoy proxy. And this picture shows that architecture. So basically we have, for each pod that's managing traffic in our component, Istio injects this Envoy proxy. It controls the traffic into and out of the microservices in this pod, and as well as being able to control them, it can then also monitor them and create these metrics. So it's creating metrics of that traffic, which it sends to this Prometheus, which is a time series database. Actually, technically, Prometheus scrapes it from the proxy, and then you can have other interfaces, like you can have Kiali, or often you build sort of dashboards using something like Grafana to show that this observability data to your operators. And we can see Prometheus at work. If I go back to this Cluster Explorer interface, I can see Prometheus at work by clicking on this and looking at the monitoring. And the monitoring is showing that I'm using Prometheus, and I want to look at the Prometheus targets. So Prometheus is scraping from a set of targets. And look at these Prometheus targets, you can see these are all the endpoints that Prometheus is scraping, and includes it's scraping this sort of this Envoy proxy. And I show more, and you can see these are the endpoints for each one of the pods that are running in our component. So this is how it technically works. And I can even go in, like normally you use a different alternative user interface like Grafana or Kiali, but Prometheus does have itself a very simple interface where I can actually run some queries myself. So for example, I can run this query, which is basically saying, show me the rate of the container CPU. So at the moment we've been showing the network traffic, but into Prometheus we've also got sort of data about sort of the CPU usage. And if I click on this and show it as a graph, So this is showing the CPU usage of all the different containers in this cluster. And you see they're all very, very low usage. There's nothing really running on them. In fact, the highest usage is actually the Rancher monitoring itself. So the monitoring at the moment is using most of the CPU, but is hardly using any of the CPU. So how do I get custom metrics from my component into this observability? Well, the first thing to do is to actually understand what sort of metrics Prometheus supports. And there's three types of metrics it supports. The first is a counter. So this is a cumulative metric that is like a single monotonically increasing counter. So you can only increase it, it's counting something, or you can reset it back to 0. So for example, we're using this to count the number of requests coming into our API. Another metric is a gauge. So this is a numerical value, but it can go up or down. So it's something typically you might be measuring something like CPU, where the CPU could go up or down, or the memory could go up or down. And the third type is a histogram. So normally you use this for things like a page response, where you're interested in like what is the histogram of page responses when you want to basically put all your responses into buckets. So responses less than 10 milliseconds, between 10 and 50, between 50 and 100, between 100 and 200, you should create buckets of response times, and then you get this metric, which is the histogram of data. So those are the types of metrics you can support, and you can actually include your own business metrics simply by adding a metrics endpoint into your component. So the example, so the product catalog, like the reference example component, which is in the Git repository. Prior to this, we just had a catalog microservice offering up the product catalog, which is the sort of core function of this component. We had a party role microservice, which is serving the party role for security, and both of these were running on a Mongo database microservice. And what we've done, we've added in a metrics microservice, which is then going to offer this metrics API endpoint to Prometheus. And what we've done for the reference example is this metrics microservice, it just registers to the catalog microservice to subscribe to the OpenAPI event notifications. So every OpenAPI has this event notification pattern where every time you create or update any resource, you create this notification event. So we've subscribed to those notification events and creating some very simple business metrics from those notification events. But this is an example. The whole idea of this is, as the creator of a component, you could decide what business metrics make sense for you to publish using this sort of mechanism. Now, so we've built that into the example. The example microservice is actually written in Node.js, and they are client libraries for Prometheus in all the sort of the common programming languages. The example is very simple. So that's the first thing. But the second thing is, how do you actually then get Prometheus? How do you configure Prometheus to scrape this endpoint? And what we've done is we've extended the component envelope. So all you need to do is to describe this metrics endpoint in your component envelope, and then these controllers automate all that configuration. So in the management section, so in this component envelope, in the management section, there's now like an extension where you can say I'm exposing an API, which is a metrics API following this Prometheus standard. So we could support different standards of metrics in the future if you wanted to. Prometheus is a very common, almost like a de facto standard for this in the Kubernetes sort of community. But we're creating this metrics endpoint where you just say which is the service where I can find this metric, what's the path to the metrics endpoint, and what port am I exposing that on. So if you put this in your component envelope, the controller that's part of the canvas automatically configures Prometheus. And we can actually go and have a look at that. If I bring my Prometheus back, if I look at if I go back into the section where I'm looking at my targets, and here you find, if I close that one down, so this one here, components are on product catalog metrics. So this is Prometheus has been configured to scrape that endpoint, which is this microservice which is offering these custom business metrics. And you can see that it's scraping periodically and getting the data from that metrics endpoint. And again, you normally build some sort of dashboard in Grafana or something like that to have a nice user interface on your metrics, but you can get a very simple view of this by actually using the graph user interface, which is part of Prometheus. So if I do a query on product, here's a product catalog API counter, and I do a query on that. So you see I'm actually getting some data for category creation notification and product specification creation notification. I can show it as a graph. As you can see, here's where I put some data before. Like normally you would do something like show the rate of that, and you can very simply add the rate by saying rate, and I can say I want to query that over like a 10-minute average. So I change my query to that. So it's turning this into a rate. As you can see, I sent it some data just after I deployed the component, and then I stopped it. But you can see this business metric of it's creating, this is the product specification, and in my Postman collection I actually create twice as many category creations as product specifications. So that's a very quick overview of the observability. So like the baseline observability you get by having a service mesh as part of the canvas, which we can automate because we have this component envelope describing the APIs, and then the ability to add custom metrics. And again, as part of the component envelope under the management section, you can expose sort of metrics APIs and automatically configure Prometheus to scrape these and get custom business metrics out of your component. And as I said at the beginning, all of this information is available in a tutorial in the ODA Git repository.